Hello, I am Hollywood Sentinel, and today I'll be going through the first video of a playlist where I'll be going through a large number of LeetCode problems, and I'll go through a tutorial, and I'll go in depth on how to solve each of these problems and the algorithms, the most efficient and most inefficient ways, and it'll just be a whole, um, playlist of solutions. And this is the first problem, titled Two Sum. And the problem essentially says, given an array of integers, return indices of the two numbers such that they add up to a specific target, and that you may assume that each input would have exactly one solution, and you may not use the same element twice. And so they pass in an array of integers, like 2, 7, 11, and 15, and they give you a target. And two of these objects in here, integers, will add up to this target. And so they guarantee that each input would have exactly one solution. So if the target input was 10, the answer wouldn't be 2 5s, because that would go against this, and that there would be exactly one solution. So that if 2 and 7 adds up to 9, then in this array there would not be a 4 and a 5, because that would go against this statement right here. And usually people go through two sum first, and this is the first problem they do. And before I forget, I'll be doing all of these in Java. The mindset for all other languages is the same, but Java is a very easy to learn language, and it's pretty I don't want to call it basic, but it's very simple and easy to learn, and like it's a good language. Yeah. If you're using another language, though, you can format whatever you do to whatever I'm doing, because as long as the logic is the same, you should get the same answer. And so this is the first solution, and this works, but it's pretty bad. The technical name for this kind of solution is brute force. And the logic behind this is, since they tell you that it has exactly one solution, if you go through this entire array, eventually you'll get the answer. And so this is a loop, and inside of it another loop. So a nested for loop, and then inside of that there's an if statement, and then we'll return a new int array if this statement is true. So nums I, nums j, so the item at I and the item at j, if they add up and equal target, then you return a new int array with these two positions, and you return null at the end, even though they tell you that it has exactly one solution, but you still have to return null, or else Java will crash in a compile error, I believe. And they'll tell you that you have to return something because you specified that you would return something. Now, if we submit the solution, you saw that I had a wrong answer before. Yeah, it's accepted. Alright, so you'll see that here I only beat 40% of Java submissions. That's pretty good, but it's not good enough, because there's this social elitist club right here, and we want to be a social elitist. Okay, like an Ivy League child, or a Google employee. So, right, I'll go through a more advanced solution now, so you can find out what that's like. Alright, hello. And right now I have Photoshop open, and I'll just draw a flowchart, or I'll use this as a whiteboard, so I can draw out how we're going to go about and create a more efficient algorithm, or a more efficient solution to our problem. And so to start out, I'm going to show you, you'll need to know that we'll be using a more advanced data structure than arrays or array lists, and so this is called a hash map. And if you don't know what a hash map is, I suggest you finish listening to this video, and then you go look hash maps up on the Oracle database. So you search up hash map API on Google, and then that'll probably be the first thing that pops up, which will be the Java documentation. So that's documentation. And Java documentation is really important as a tool for developers and basically everyone. and even if you have a lot of experience, you'll still want to visit the Java docs quite a bit, so you don't mess anything up. And there's a lot of hidden great functions like string.reverse, and more than that actually. And so hash map is a data structure that contain data structure. I'm sorry, data blah blah blah. So it has a key, and every key has a value, and value, and every key in a hash map is unique, and every value in a hash map there can be duplicates, but every key has to be unique. And so we'll be using a hash map because a hash map is incredibly efficient when it comes to lookup time. And so you have this, right? And for an array, if you do, let's say I have an array called R, and if you call R and 3,000, right? In order to get an element out of this array, it'll have to go through 1 and then all the way to 3,000. And that boosts up your runtime from ON. And it'll still be called ON, but it'll be like really inefficient. Inefficient ON, right? But with a hash map, instead of going through all 3,000, if you call a hash map and if your key equals 3,000 and you look up on a hash map, it'll go straight to 3K. And that's incredibly important because it's not like an array where it'll has to go through all elements beforehand. And so a key in a hash map can be any object. It's predefined, like in an array list. The value can be any object, like an array list. So it's kind of like a dual array list, but it's a lot faster. The lookup is a lot faster because an array list, like an array, it goes through all of them chronologically. Okay, but a hash map, it goes straight to the point, and so it's really fast, and that's great. And so down here, I'll make up a data set, so it'll be something like 11. Let's see, there's a 15 there. Right now it's 22, and it's 10:22, and today is the 13th, and it's the June, and it's the 2018, and it's also 2018. And so we'll just add up any two of these. So 2 plus 20 equals 30. Alright, that took me like 5 seconds to get 10 plus 20. Alright, so it's this one, and it's this one. Beforehand, we have to make sure that no other objects in here add up to 30. And glance through, and you'll find out that they totally don't. Alright, so now we'll draw our hash map. Oh, that's not a very straight line. Straight line, please. Oh, the drawing gods have blessed me. Alright, so on this side we have our keys. This is our value. This is a bit too long, so we'll just ignore this one and ignore this one. Right, so now it's 0, 1, 2, 3, 4, 5, and 6. So we have 6 objects in our 7 objects because it starts at 0, so it's 0 based, and so there's 7 objects, and the value will be our oh, this one doesn't count, so we only have 5. Oh my, look at these math skills. Alright, so the value will be the index right here, because based on a number here, we can look up the index, and so 0, 1, 2, 3, 4, and 5. And then the key will be these numbers, and I won't put them in yet, so we'll start here. This is the 0th index, so the value is here. Oh, I haven't actually gone over the logic of this yet. So every time we add a new object here, we will know exactly what this object is. And so we will add this here, and then we'll look up if there is a key in this hash map that is 30, which is our target, minus the current number, which is 11. Right? And then that'll be the x that we're looking for. And then we look up in this table, and then we'll find the value. And so we'll return the value at which we found this number, and then the value of the hash map lookup. And that's actually the answer. That's it. The end. It's really fast. And so that's the logic, is essentially what we're going for. And 30 minus 11 is x. And 30 minus 11, if you do the quick maths, you'll find out that it's 19. And since this key is currently only occupied by 11, you'll be like, oh, whatever, we'll just pass it by. Next one is 22. 22 is the first index, second index technically, but it's index number 1. And so this is what we'll be looking, and so if you do 30 minus 22, you'll find out that we're looking for 8. And since 8 is not in this, pass it by. So next, 10. 10 is one of the numbers that we're looking for, because we're looking for 20, and we're looking for 10. But since, if you look up here, 30 minus 10 equals 20. But 20 is not currently in our key, so we'll just pass that by. And the next number is 6. 30 minus 6, 24, not in here. Next number, 18. 30 minus 18, oh my, this lines up like that. This lines up like that. 30 minus 18 is 12. And since 12 is not in here, then we'll just pass that by again. Now we have the last index, 30 minus 20. That equals 10. And when you do hashmap dot index of, or not index of, dot value of a specific key, if that exists, then you return, then you find out that this is totally here and that the value is 2. And so you return 2, comma, the index at which you found this 20, which happens to be 5. So you return 2, comma, 5. And this is a little bit messy, but it's perfectly fine, because hopefully you understood what I was trying to get through. And so essentially what we have is a loop using a hash map, concurrent lookup, and as we go through, eventually we'll get our answer. And this, if you want to get technical, the runtime for this is on. The runtime for brute force is on squared. And so if you think about it, on is a lot better than on squared. This is only worst case though. Best case scenario for this is that the runtime is, I believe, 1. And the worst case scenario for this is like also 1. Well, that's fine. You don't care about best case. You only care about worst case. Because whatever happens, the people who design LeetCode will throw at you worst case scenarios, because they're ballers like that. Alright. And so now that that's done, this is our whiteboard. It's kind of messy, but this is fine. And I'll just code this up now. But before that, let's visit the Oracle API documentation, Java docs. Bye. Okay, welcome back. Not really welcome back. Now, here we are. This is Java docs, Java Platform Standard Edition 8. And this is a hash map. This is the API for hash map. You'll see it here, that hash map, when you declare a hash map, takes in 2 parameters. The first word is K, the other one is V. K stands for key, V stands for value. And so the type of keys maintained by this map, and the type of mapped values, which is K and V. And if we go through the hash map, we'll find a bunch of really useful, what are they called again? They're called functions. Oh my. Alright, I'll go commit suffocate later. But now, the most important one right now for us is this. It's get. And if you click on it, it'll just drop us down to where the function itself is explained in detail. So public v get. So public, it returns a value, and an object of type value, that whatever you declared it as. And so it takes in an object, key, and it returns the value to which the specified key is mapped, or null if this map contains no mapping for the key. And so essentially what we'll do is, instead of, I said value of, but we'll just get the key, and if it's not null, then we return, get the value. If it's not null, then we return the value, comma the current index at which we are currently at. That's pretty simple. So let's code this up. In here, we have the brute force solution that we used before. We'll just go ahead and delete everything here, except for this for loop and this return statement. So we'll call this up hash map, and we'll call it map. Remember, when you declare hash map, like an array list, you have to declare the type of key and the type of value stored. And so hash map equals new hash map. And of course, you could leave this empty, but because we are a traditionals and we're not super elite 1337 ballers, we'll put a value in there just so someone can read our code correctly. And so for everything in here, I is less than nums.length minus 1. And it's not minus 1 because it's nums.length. That was only there before because we needed that statement. Now hash map, and then if map dot get, and our key is, so nums.length, or not nums.length, it's target with one e minus nums, and the object at this value right here, which is the value at I. If you get the target and it's not null, then you return this value, a new int array of this value, comma I. So I is the value that you're currently at, and this is the value of things that you're gonna get. And then if this, and then else, if you don't need to put an else statement, because if this doesn't go through, if this does go through, it'll return and it'll just blow out of the whole loop entirely. And so if not, then you map dot, and we have to go back here and we have to find out, I believe it's called like insert put, it's called put. So put a new key and a new value. So map dot put, and we are looking for target minus nums I, and then you put in another one that is I. And that's the whole thing in a nutshell, really. And it's only a few lines of code, and it's short because this is an easy problem. Hopefully it goes through. It's judging, so we didn't have a compile error. Oh no. What happened here? Right. No. That means that we did something wrong. I'll be right back. Alright, I know what the problem was. The problem was that before we had this target minus nums I. I was an idiot, so I put the target minus nums I here, and so this is just nums I. And essentially we're mapping the value of which we find at this index, and then the index right there. So we'll run this again. Right, and that's the answer. And we can add some more custom test cases as well. Like, what else do they don't have anything else here. So we'll do the custom test case that I'll just make up a random one. So 11, 12. Oops. Double. Something like that. And the target that we want is 443. Something like, I don't know. And so the answer will be that they're judging and we're judging at the same time. This is really slow for some reason. Expected answer is 0,3. Answer is 0,3. So we'll just submit the solution. It looks about right. This is probably about right. I'm going to turn up the brightness because I want the brightness when the solution comes out. And it's accepted, yay. And we'll hit more details. And yes, you beat 60% of all Java submissions. While that may not be very impressive, we're still within this major chunk. Back before we were back here, and this back chunk back here, and as long as you're within this bell curve right here, you'll know that you're good. And this percentage entirely depends on how good LeetCode servers are while you are running your submission. And as long as you're somewhere around this bell curve here, you'll know that your submission is pretty good. And honestly, the percentage at which you get completely depends on LeetCode. And so if you don't get a percentage that you like if you have OCD, or if you have like severe need to show like severe need to show incredible impressiveness, then you can just submit again. And you see we submit again, and your runtime beats 93%, 0.27% of Java submissions. And that's pretty good. But we were here before, we're here now, and it's the same thing, really. And we use the same code, because I haven't changed it at all. And it only depends on LeetCode itself. So whether LeetCode does good, whether LeetCode does bad, that's not your problem. And you can look up here. Look, this is a very similar thing, except they use arrays, and it's pretty much what we used, kind of, except, yeah, it's kind of similar to what we did, but it's not the same. Anyways, hash maps do have faster lookup times, but maybe they ended up there because they had a good day, and they had a good LeetCode day, where LeetCode servers were on point. They had their fans going on fleek. They had all of their GPU going like AWOL, not AWOL, on fleek, yo. They were like hella lit. So that's pretty much it. Alright, next time I'm going to cover Two Sum 2, which is the next problem, and look forward to that video. Bye.